Now we are starting with December 2018 question paper, and this is the first part of that question paper. Okay, so let us see what is our first question. Now, as we all know that in first question we have to solve any 5 and each question comprises of 4 marks. Okay, so now a waveform is given and we have been asked to find RMS value of the waveform. Okay. So for this we can very well understand that this is a symmetrical signal, correct? And if this is t, then this time period is going to be t by 2 and the maximum value is specified to be Im, right? Yes. So here a very important part is, see, we have to calculate the area, right? Now it is a symmetrical figure, correct? It means that, now let me draw it here. Now suppose this is the waveform. So I have divided it into 2 parts. This is part number 1 and this is part number 2. So if I calculate the area of part number 1, then it will be same as the area of the second part, correct? So what is going to be the total area? Total area will be, I can calculate the area of any of these parts and I can twice it or multiply it by 2. Correct? So this is how we are going to solve it. Okay, fine. Now after this, let us understand how to write the equation for the current, because we want the equation for the current. And before that, let us specify the time period. So time period is greater than 0 and it is for less than t by 2. Okay. Now what is going to be the slope? The slope is going to be I is equal to y by x. So what is the value of y? It is Im, correct? And what is the value of x? We are taking it half, so it is t by 2 and it has to be multiplied by t. So this is the slope. So it means that the equation for I becomes, this 2 goes to the numerator, so it becomes 2Im by t, that is a capital T, into small t. So we have to remember this equation now. Okay, understood? Fine. So now let us write the RMS equation. So we all know that for RMS we have to take, the square and then the square root, and for ease of calculation we always start with the square and at the end we take the square root on the both sides, correct? So here I square RMS will be twice the area of, what is the limit? Limit is 0 to t by 2, correct? And here the current square has to be taken. Right? Now this has to be divided by the total area. Now what is the total area? It is T, because I am calculating the area for one full cycle, isn't it? So this becomes the total area. So I will just be putting the value here. So it is 2 by T, integration from 0 to 2 by T by 2, and then I'll be putting the value, which is 2Im upon T, correct, multiplied by T, and this whole square dt, correct? Okay, yes. So now we will be writing the next equation. So after squaring, after squaring the equation, since we require this part, I am not erasing this part. Yes. So now what will be I square RMS? I square RMS will be 2 by T. Now please pay attention here. we are integrating it with respect to small t. So if you consider this whole value with respect to small t, only this is that variable. All other things are constant. So what I'll do is I'll take all other values outside the integration sign. Fine. Okay. So I get 2Im upon t whole square. And then integration 0 to t by 2 and t square dt. Correct? So let me solve this now. So it will be 2 by t and the square value will be 4 Im square upon t square. And what will be the integration of t square? It is t cube by 3 from limit 0 to t by 2. Correct? Yes. So after this, let us solve this. 4 into 2 becomes 8 Im square upon denominator becomes t cube, correct? And now we will be putting the value. So we need not solve it for 0 because anyways it is going to be 0. So what we will be doing is we will put t by 2 in place of t, that cube divided by 3. So what do we get here? 8 Im square upon t cube multiplied by, here it becomes t cube upon 8 and 3 was already there. So t cube and t cube get cancelled, 8 and 8 also get cancelled, and finally we get the value to be Im square by 3. But this was I square RMS, right? So after this, taking the square root on both the sides, I get IRMS is equal to Im upon square root 3. So this is how the RMS value is calculated. Fine. Okay, so let us see the